Welcome to This Explainer. Today, we're diving into something really fascinating. We're going to explore how the profound historical shifts that happened in quantum mechanics actually give us a direct, highly practical blueprint for governing today's most complex systems. We're stepping way beyond just the physics here to see how we can essentially learn to control the uncontrollable. Here's a quick look at where we're headed. We'll start with what happens when our sensory intuition fails, move into the quantum modeling revolution, and then look at finding order in chaos. After that, we'll introduce the energetic paradigm and wrap up with some real-world applications for complex systems. All right, let's jump right into part one, when sensory intuition fails. So let's start with a really fundamental truth. There is a massive, sharp contrast between our classical intuition and abstract models. You know, as humans, we naturally build our understanding of the world from what we can literally touch, see, and hear, right? It's just how we're wired. But scientific progress actually happens by abstracting away from that direct perception. Think about Copernicus for a second. The intuitive, Earth-centered view of the universe matched our everyday experience perfectly. I mean, the sun literally looks like it's moving around us. But Copernicus proved that intuitive picture was completely wrong, and that taught us a massive lesson. A useful model doesn't need to look like everyday reality. It just needs to identify the variables that allow for actual prediction. What's super fascinating is how this exact same problem showed up in early physics. When physicists first discovered the nucleus, they naturally tried to model atoms like tiny solar systems. You had a nucleus acting like the sun, and electrons orbiting it like little planets. And honestly, it felt incredibly intuitive. But, well, classical electromagnetism proved this surface-level analogy was structurally just wrong. If electrons were actually orbiting like planets, they would constantly radiate energy and just rapidly spiral into the nucleus. Matter as we know it would literally collapse. So the classical concepts completely failed because they were relying on the wrong control variables. That brings us to our second section, the quantum modeling revolution. To fix this complete breakdown in our understanding, physics had to undergo this continuous human evolution away from direct observation, moving toward purely abstract mathematical models. Bohr kind of kicked it off by imposing discrete electron orbits, but he was still kind of clinging to that old visual intuition. It really wasn't until Heisenberg, Schrödinger, and Dirac stepped in that we fully embraced abstractions. They exposed the variables that truly mattered and essentially left everyday common sense completely behind. And that brings us to Werner Heisenberg. He was a real game changer because he fundamentally shifted physics with a core governance principle. He basically said, stop trying to describe unobservable electron trajectories. Stop trying to track what you can't see. Instead, build your theory around what you can actually observe, like spectral frequencies. So the absolutely crucial takeaway here is this. A system cannot be effectively controlled or understood through variables that you can't measure, bound, or connect to an actual intervention. Then Erwin Schrödinger came along and gave us wave mechanics. Now, Schrödinger's equations didn't necessarily make quantum mechanics look any more like our everyday world, but they provided something incredibly important, a solvable interface. This proved that it simply doesn't matter if an abstract model feels intuitive or totally weird. The only thing that actually matters is whether it gives us a reliable interface for prediction, verification, and intervention. It brilliantly separates how comfortable a story feels to us from how valid our control over the system actually is. Let's move on to Paul Dirac to see how this builds even further. Dirac managed to merge quantum theory with special relativity, and by strictly following mathematical constraints, his equations ended up predicting something completely absurd at the time: antimatter. He didn't just spot it in a lab first. The math demanded it, and sure enough, the positron was discovered later, proving him absolutely right. This perfectly illustrates that when constraints are correctly modeled, strict theoretical consistency can actually reveal hidden entities and missing components that literally nobody expected to find just by looking at the surface. But as we dive deeper into highly complex environments, a massive control problem starts to emerge. Think about it. How do you control a system when individual paths completely disappear? What happens when a system is so chaotic, so overwhelmingly complex, that we simply can no longer track individual trajectories at all? This leads us right into Section 3, Finding Order in Chaos. So this introduces us to the fascinating science of quantum chaos. In classical chaos, think of the famous butterfly effect, a tiny change in initial conditions radically alters the path of an object, making it practically impossible to track. But in quantum mechanics, as Heisenberg taught us, those individual classical paths don't even exist as observables. So what do? Well, researchers like Eugene Wigner used something called random matrix theory. Instead of trying to hopelessly follow every single chaotic path, they found deep statistical order in the distributions and correlations of atomic energy levels. They basically stopped looking at the individual pieces and started looking at the overall pattern. The overarching lesson from quantum chaos is simply this. When detailed tracking completely fails, when you literally can't follow every moving part, you can still govern a system by measuring statistical structures, bottlenecks, and invariants. You really don't need to know where every piece is. You just need to understand the shape of the system's behavior. Okay, moving to section 4, the energetic paradigm. So, how do we apply these incredible, century-old physics lessons to modern complexity? Well, we introduce a framework called the energetic paradigm, or EP for short. Now, just to be super clear, EP isn't claiming to replace physics. Not at all. Instead, it takes this exact intellectual lineage, the move away from intuition, the focus on observables, finding statistical order in chaos, and it turns it into a practical governance architecture for today's complexities. It essentially asks the exact same hard questions of modern systems that Heisenberg and Schrödinger asked of the atom. AP draws a direct, actionable line from history to today. It translates Heisenberg's focus on observables directly into things like logging AI agent states. It takes Wigner's statistical matrices and applies them to detecting market regimes or even disease subtypes. It really is the ultimate translation of quantum discipline into actionable rules for AI, biological systems, and financial markets. To pull this off, EP deploys 6 highly specific analytical steps to deconstruct any complex system. It forces us to ask, what are the real causal variables here? Which of those can we actually measure and verify? How is money, energy, or information flowing through the system? What are the boundaries? By stepping through these exact questions, we reconstruct the true causal state space of a system, rather than blindly trusting its often misleading surface appearances. And finally, Section 5, Applications for Complex Systems. Let's look at how this EP control stack actually governs real-world complexity today, instead of just measuring symptoms, starting with artificial intelligence. Right now, most people evaluate an AI just by looking at how fluent and impressive its outputs are. But remember what we learned from the atomic solar system model? A model can look totally right on the surface while being structurally broken underneath. EP forces us to stop staring at just the outputs. Instead, we monitor internal model states, we audit tool usage, map incentive pressures, and track failure clusters. That is how we build a true observable control layer. Now, let's apply this to biology and medicine. Too often, we just name a disease by its surface symptoms and try to treat that label. But EP treats the body like the complex system it is. Rather than just fighting a named symptom, EP looks for structural control. It analyzes metabolic gradients, maps out nonlinear feedback loops, and measures specific observable cell states to find precise, safe intervention points that won't cause the whole system to spiral out of control. And for organizations and markets, the exact same rules apply. EP stops focusing on generic outcome metrics or superficial benchmark scores. Instead, it tracks the actual flows of capital, attention, and decision rights. Just like Dirac's equations revealed hidden antimatter, mapping the strict constraints of a business can reveal hidden veto points, misaligned incentives, and massive information bottlenecks that nobody even realized were there. This completely shifts how we approach analysis. Ordinary analysis stays right on the surface. It generates outputs, looks at benchmark scores, and basically hopes for the best. The energetic paradigm, on the other hand, completely transforms chaos into a diagnosable target. It builds a full technology stack of measurement, intervention, and governance. It's exactly the same way quantum theory evolved into a technology stack that eventually gave us lasers and semiconductors. Ultimately, the history of quantum mechanics proved one absolutely inescapable fact. Mastering reality means we have to leave our everyday intuition behind. Complex reality requires better abstractions, not stronger intuition. And the energetic paradigm brings this exact scientific discipline to the overwhelming complexity of our modern world. Which leaves us with one final, crucial question to consider today. When you look at the complex systems in your own life, your business, or your research, are you still relying on comfortable intuition and surface appearances, or are you ready to map the variables that truly matter? Thank you so much for joining me on this explainer. Keep asking the hard questions and always look beneath the surface.